March 1st, 1982. 3:57 a.m. Universal Time. A titanium sphere, no larger than a washing machine, plummeted through an atmosphere so thick it could crush a submarine. The temperature outside? 457 degrees Celsius, hot enough to melt lead, zinc, and tin simultaneously. Engineers in Moscow had designed this machine to survive 32 minutes. It lasted 127. In those 2 hours, Venera 13 accomplished something no spacecraft had ever done before, something that, 40 years later, no machine has ever repeated. It recorded the sound of another world. But here's what makes this story truly extraordinary. The Soviets had tried, and failed, to reach Venus 25 times before this moment. 25 spacecraft, 2 decades of disasters. Crushed probes, lost signals, parachutes that ripped apart, cameras that never opened. What drove them to keep trying? And why did they succeed when everything in the universe seemed designed to destroy them? The answer begins not with rockets, but with a single man who spent years in Stalin's gulags, and who would later become the secret architect of the Soviet space program. In 1961, Venus was the most mysterious object in our solar system. Astronomers knew almost nothing about what lay beneath its perpetual blanket of clouds. Some believed it was a swampy tropical world, a prehistoric Earth covered in steaming jungles and ancient oceans. Science fiction writers imagined Venusian civilizations, alien forests, even intelligent life hiding beneath that white veil. Venus was, after all, Earth's twin, nearly identical in size, similar mass, same basic distance from the Sun. And so, when Soviet chief designer Sergei Korolev stood before a room of engineers in Moscow and announced that the Soviet Union would be the first nation to reach Venus, it seemed like a reasonable goal. After all, Korolev had already accomplished the impossible. He had launched Sputnik. He had put Yuri Gagarin into orbit. Surely Venus was simply the next step. But Korolev was hiding something from almost everyone in that room. This soft-spoken man with the tired eyes had spent 6 years in Soviet labor camps, arrested during Stalin's Great Purge on fabricated charges of sabotage. He had worked in the Siberian gold mines of Kolyma, one of the deadliest places on Earth. He had nearly died of scurvy. His jaw had been broken during an interrogation and never healed properly. And yet, impossibly, he had survived. He had clawed his way back into the Soviet scientific establishment, and now he was racing against time, and against the Americans, to prove that socialist science could conquer the cosmos itself. But there was a problem that would take 20 years and 25 failed missions to fully understand. Venus wasn't Earth's twin. It was Earth's nightmare. What Korolev and his engineers could not have known, what no human being knew in 1961, was that beneath those beautiful white clouds lay an environment so hostile, so utterly alien, that even describing it sounds like science fiction. The surface temperature on Venus exceeds 460 degrees Celsius, hotter than Mercury, despite being nearly twice as far from the Sun. Hot enough to melt lead in seconds. Hot enough to glow red in the dark. The atmospheric pressure? 90 times greater than Earth's. Standing on Venus would feel like being 900 meters underwater, without a submarine. The weight of that atmosphere would crush a human body like an empty soda can. And the atmosphere itself? 96% carbon dioxide, laced with clouds of sulfuric acid that rained down in droplets so caustic they would dissolve metal. This was the world the Soviet engineers were trying to reach. They had no idea what was waiting for them. But here's the question that should haunt us. How do you build a machine that can survive in hell? And more importantly, why would anyone keep trying after failing so many times? February 12th, 1961. The Soviet Union launches Venera 1, the first spacecraft ever designed to reach another planet. It is an elegant machine, almost beautiful in its simplicity. Spin-stabilized, packed with instruments, weighing 1,400 pounds, nearly 8 times heavier than Sputnik. 7 days after launch, the telemetry fails. Venera 1 disappears into the void. This would become a pattern. Venera 2, launched November 1965, overheated before reaching Venus, all communication lost. Venera 3, launched 5 days later, its communication system failed in transit, but the spacecraft did reach Venus. On March 1, 1966, it slammed into the planet's surface at terminal velocity. It was the first human-made object to touch another world. And it told us absolutely nothing. Now, imagine you are a Soviet engineer in 1967. You have failed 5 times. Your American competitors have already succeeded. Mariner 2 flew past Venus in 1962, becoming the first successful interplanetary mission in history. Do you give up? The Soviet leadership did something remarkable. They transferred the entire planetary exploration program from Sergei Korolyov's overworked bureau to a new organization, NPO Lavochkin, headed by a telecommunications engineer named Georgy Babakin. Babakin was not a rocket scientist by training. He was, above all else, a methodical man, obsessed with testing, with quality control, with understanding why things failed before attempting them again. Under his leadership, the Lavochkin Bureau subjected every component to rigorous examination. They discovered, for instance, that the previous Venera landers, when placed in centrifuge tests, failed at half the G-forces they were supposed to handle. The earlier spacecraft had been doomed from the start. October 18, 1967. Venera 4 enters the Venusian atmosphere. For 93 minutes, it transmits data as it descends by parachute. The readings are shocking. The atmosphere is not Earth-like. It is a furnace. 96% carbon dioxide, temperatures exceeding 250 degrees, and rising. Pressure building toward levels that would destroy any existing spacecraft. And then, at 25 atmospheres, 25 times the pressure at Earth's surface, Venera 4 is crushed like an egg. It never reaches the surface. The Soviet engineers now understood the magnitude of their task. Venus was not a tropical paradise hiding beneath clouds. It was a pressure cooker surrounded by acid. Any spacecraft that hoped to survive would need to withstand conditions more extreme than anything on Earth. More extreme, perhaps, than anything humans had ever engineered for. And yet, they kept building. Venera 7, launched August 17, 1970, was designed differently. Its titanium pressure vessel was built to withstand 180 atmospheres, almost twice what scientists expected on Venus. Its parachute was smaller, designed to fall faster, giving the spacecraft less time to be cooked by the atmosphere. On December 15, 1970, Venera 7 entered the Venusian atmosphere. Its parachute ripped apart. The spacecraft plummeted toward the surface, tumbling out of control, and slammed into Venus at 17 meters per second. And somehow, impossibly, it survived. For 23 minutes, Venera 7 transmitted data from the surface of another planet. The signal was weak, The antenna had been knocked out of alignment during the rough landing, but the data was unmistakable. Temperature, 475 degrees Celsius. Pressure, 90 atmospheres. Venera 7 had become the first spacecraft to successfully land on another planet and transmit data back to Earth. But there was still one thing the Soviets had not accomplished. They had not seen Venus. What did it look like down there, beneath those endless clouds, in that crushing, scorching darkness? That question would obsess Soviet engineers for the next 11 years, and it would lead them to build the most extraordinary spacecraft ever conceived. Venera 13. By 1981, the Lavochkin engineers had learned hard lessons from 15 years of failure and partial success. They knew that the parachutes could tear. They knew that cameras could fail, lens caps refusing to pop off, sealing the eyes of their spacecraft forever. They knew that every second on Venus was borrowed time, a race against the relentless laws of thermodynamics. But they also knew something else. They had gotten better. Venera 13 represented the pinnacle of Soviet planetary engineering. Its lander was a masterpiece of survival technology, a hermetically sealed titanium sphere designed to be pre-cooled to -15 degrees Celsius before separation, giving the electronics a head start against the heat. Inside that sphere, blocks of lithium nitrate trihydrate served as thermal accumulators, an ingenious cooling system that exploited a basic principle of physics. When lithium nitrate melts, it absorbs enormous amounts of heat energy. By packing the spacecraft with this material, engineers created a thermal buffer that would slowly absorb the Venusian heat, buying precious minutes of survival time. But the most remarkable features of Venera 13 were not defensive. They were scientific. The spacecraft carried 2 color panoramic cameras, protected by quartz windows and titanium lens caps that would be pyrotechnically ejected after landing. It carried a drill, a mechanical arm designed to collect soil samples from the Venusian surface, deposit them into a sealed chamber maintained at 30 degrees Celsius, and analyze their composition using X-ray fluorescence spectroscopy. It carried a spring-loaded penetrometer to measure soil compressibility. And, most remarkably, it carried microphones. Microphones on Venus. Think about what that means for a moment. The Soviet engineers weren't just trying to survive Venus. They wanted to hear it. They wanted to record the wind that blew across an alien world. They wanted to capture the sound of their drill biting into soil that no human hand would ever touch. It was audacious. It was perhaps even foolish. But it was also, in its own way, deeply human. On October 30th, 1981, at 0604 Universal Time, Venera 13 lifted off from Baikonur Cosmodrome atop a Proton K rocket. 4 months later, after 2 mid-course corrections and 300 million kilometers of travel, it approached Venus. On March 1st, 1982, the descent module separated from the cruise stage and plunged into the Venusian atmosphere. What happened next would become one of the greatest achievements in the history of space exploration. But first, there was the descent. Imagine falling through an atmosphere thick as syrup, hot as a blast furnace, opaque with sulfuric acid clouds. The parachute deploys at 63 kilometers, but unlike earlier missions, it releases after just a few minutes. Below 50 kilometers, the spacecraft falls freely, using only air braking to slow its descent. This is deliberate. Every second saved is a second less of exposure to the killing heat. The atmosphere grows denser, thicker, more resistant. The spacecraft slows despite having no parachute. By the time it reaches the surface, it is falling at just 7 to 8 meters per second, a brisk walking pace. At 3:57:21 Universal Time, Venera 13 touches down. It lands on flat basaltic rock, surrounded by dark, fine-grained soil. The sky above is orange-brown, the light filtering through 60 kilometers of sulfuric acid clouds. The temperature is 457 degrees Celsius. The pressure is 89 atmospheres, 89 times the weight of Earth's entire atmosphere pressing down on this single, fragile machine. And the clock is ticking. What happened during the next 127 minutes would change our understanding of another world forever. But the question that haunted the engineers back in Moscow was simpler. Would anything work at all? The first lens cap fires. In Moscow, engineers hold their breath. This is the moment that has defeated them before, on Venera 9, on Venera 10, on Venera 11 and 12. Lens caps that refused to separate. Cameras that stared forever at nothing. The cap ejects. The camera begins scanning. And for the first time in human history, color images begin streaming back from the surface of Venus. What the camera reveals is not a lifeless wasteland. It is something stranger. An alien landscape that is, somehow, recognizable. Flat, angular rocks, basaltic slabs like frozen lava flows, dark, fine-grained soil stretching to a horizon hidden in amber haze. The colors are orange and brown, filtered through the thick Venusian atmosphere that blocks almost all blue light. The spacecraft itself is visible in the frame. The edge of the landing platform, the mechanical arm, the distinctive half-moon shape of the ejected lens cap resting on the soil. It looks, impossibly, like a beach at sunset. But the cameras were not the only instrument coming to life. The mechanical drilling arm extends. Its motor whines against the resistance of Venusian rock. Within minutes, it has collected a sample, fragments of alien geology that no human will ever touch. The sample is transferred into the sealed analysis chamber, where the X-ray fluorescence spectrometer goes to work. The results, transmitted back to Earth, reveal that Venus's surface is composed of weakly differentiated melanocratic alkaline gabbroids, a type of rock similar to terrestrial leucitic basalt. In plain language, the rocks of Venus are volcanic. They formed from lava, just like so much of Earth's crust. Two worlds, so different in every other way, sharing a common geological heritage. And then there was the sound. The microphones on Venera 13 recorded something no human ear had ever heard. The voice of another planet. What you're hearing is the Venusian wind. Slow, heavy, dense, barely half a meter per second. A gentle breeze by Earth standards, but moving through an atmosphere so thick that even this whisper carries tremendous force. You can hear the lander striking the ground, the explosive crack of the lens cap being ejected, the grind of the drill biting into rock, the whir of internal systems struggling against the relentless heat. This is the first recording of sound on another planet. It remains, to this day, one of the most haunting pieces of audio ever captured. Back in Moscow, the engineers watched their displays with growing disbelief. Venera 13 had been designed to survive 32 minutes. 1 hour passed. Then 90 minutes. The spacecraft kept transmitting. Temperature readings held steady at 457 degrees. Pressure at 89 atmospheres. Every instrument continued to function as if unaware that it was supposed to be dead. At 127 minutes, 2 hours and 7 minutes, Venera 13 finally fell silent. The heat had won. The laws of thermodynamics could not be denied forever. But in those 127 minutes, Venera 13 had accomplished more than anyone had dared hope. It had captured 14 images of the Venusian surface. It had analyzed the soil composition. It had recorded the sound of wind on another world. It had proven that with enough determination, enough ingenuity, and enough willingness to fail, human beings could touch even the most hostile places in the universe. But this story has one more chapter, because 4 days later, Venera 13's twin would land on Venus. And something would go terribly, absurdly wrong. Venera 14 was identical to Venera 13. Same design, same instruments, same mission. It landed on March 5, 1982, about 950 kilometers southwest of its sibling, on a basaltic plain near Phoebe Reggio. Everything went according to plan. The parachute deployed, the air braking worked, the spacecraft touched down safely and began transmitting. The cameras fired. The lens caps ejected perfectly. And then, something ridiculous happened. One of the lens caps landed directly beneath the spring-loaded arm designed to measure soil compressibility. When the arm extended and pressed down, exactly as designed, it did not touch the Venusian soil. It touched the titanium lens cap. For 57 minutes, while Venera 14 transmitted invaluable data about the Venusian atmosphere and surface, its soil compressibility readings were completely worthless. The probe had traveled 300 million kilometers. It had survived temperatures that would melt lead. It had endured pressures that would crush a submarine. And then, it had measured the hardness of its own lens cap. In the grand scheme of space exploration, this was a minor failure. Venera 14 still returned critical data, still captured images, still contributed to our understanding of Venus. But there's something deeply human about this moment, something that captures the impossible difficulty of exploring other worlds. You can plan for everything. You can engineer for conditions that would destroy any machine on Earth. You can spend 20 years perfecting your technology. And then, a tiny piece of titanium, weighing just a few grams, lands in exactly the wrong place, and part of your mission is lost. The Soviet engineers didn't give up after the lens cap incident. They launched Venera 15 and 16 the following year, orbiters equipped with advanced radar mapping systems that produced the most detailed images of Venus's surface ever created. But no Soviet spacecraft would ever touch the surface of Venus again. The program ended. The Cold War wound down. The Soviet Union itself would dissolve less than a decade later. And for the past 40 years, no human-built machine has landed on Venus. The images from Venera 13 and 14 remain the only photographs ever taken from the surface of our nearest planetary neighbor. The sounds recorded by Venera 13 remain the only audio we have from another world. This raises a question that should trouble us. Why haven't we gone back? Venus remains, in many ways, more mysterious than Mars. We have sent rovers to crawl across the Martian surface for years at a time. We have mapped every crater, every canyon, every ancient riverbed. But Venus? We have a handful of photographs, taken 40 years ago by machines that survived for less than 2 hours. We have a few minutes of audio. We have soil samples analyzed by instruments that would be considered primitive by modern standards. And that's it. NASA is now planning to return to Venus with the Da Vinci and Veritas missions, targeted for launch in the late 2020s. Russia has proposed Venera D, a new generation of Venus explorers that would include landers, orbiters, and perhaps even atmospheric balloons. But as of today, December 2025, Venera 13 remains humanity's greatest achievement on the surface of Venus. A titanium sphere, pre-cooled with lithium nitrate, falling through acid clouds, landing on volcanic rock, drilling into alien soil, recording the whisper of an alien wind. Built by engineers who had failed 25 times before, engineers who worked under a political system that punished failure harshly, engineers who never gave up. Sergei Korolev, the visionary who started the Soviet planetary exploration program, died in 1966, before any of his Venus probes successfully reached the surface. The years in the Gulag had broken his health. He never saw the photographs from Venera 9, the first images from another world. He never heard the wind on Venus. Georgy Babakin, who transformed the program through methodical testing and engineering excellence, died of a heart attack in 1971, just months after Venera 7 achieved the first successful planetary landing. He never saw Venera 13's triumph. These men built something greater than themselves. They built a legacy of persistence, of innovation, of refusing to accept that some things are impossible. The next time you look up at the evening sky and see Venus, that brilliant point of light that the ancients named for the goddess of love, remember what lies beneath those clouds. A world of crushing pressure and scorching heat. A world where sulfuric acid rains from the sky. A world that destroyed every machine humanity ever sent to its surface. But also a world that human ingenuity managed, briefly, to touch. 127 minutes. That's all we got. But what extraordinary minutes they were. What changed because of Venera 13? We learned that Venus's surface is geologically young. Volcanic activity has resurfaced the planet multiple times. We learned that its rocks share a heritage with Earth's own volcanic formations. We learned that sound travels differently through dense carbon dioxide, that the wind on Venus is slow but heavy, that somewhere beneath those eternal clouds lies a landscape both alien and strangely familiar. But perhaps the most important thing we learned was about ourselves. We learned that human beings will keep trying, even after 25 failures, even against impossible odds, even when the universe itself seems designed to destroy us. Venera 13 lasted 127 minutes in conditions that should have destroyed it instantly. In those 127 minutes, it gave us something beyond data, beyond images, beyond recordings. It gave us proof that the impossible is simply the not yet achieved. The surface of Venus has not been touched by a human-built machine since 1985. The sounds recorded by Venera 13 remain the only audio ever captured from the surface of another planet. The Soviet engineers who built these spacecraft are now all gone, but their achievement endures.